Hello, welcome back to GeoBiz, Industry Upbeat Live Panel Discussion. We all know it has been 29 years that the first set of microsatellites have been launched by Soviet Union in 1986, and since then small satellites have become even smaller and more sophisticated. Well, the advances in microelectronics, GNSS and a vast array of elite technologies is facilitating reducing the costs of manufacturing and launching of the satellites. And this has opened up the market completely with new and a new set of people joining the small satellite business and taking the opportunities forward. So not just in the communications, earth observation, weather, education, you name, and there is a scope for small satellites to play a role. So to discuss on the trends in the small satellites and the application areas, we have an esteemed panel today in the studio, and I introduce Annie Milgrace, President and CEO of Planet IQ. Thank you, Annie, for joining us on GeoBiz live panel discussion. Annie has been a geographer and remote sensing scientist by training, and she has about more than 30 years of experience in geospatial sector and space sector. She has also worked with Booz Allen and Fugro Earth Data and other companies before moving to Planet IQ. And on my left, we have Frank McKenna, President, Satellite and Services Division, OmniEarth. Frank also has more than 30 years of experience in aerospace, electronics, space and IT businesses. He has worked with organizations like Lockheed Martin and International Launch Services before moving to OmniEarth. Welcome, Frank. Thank you for joining us on GeoBiz. And to start with the panel discussion, Annie, can I ask you to introduce about your company, what OmniEarth is doing and how it is taking the small satellite business forward?
Sure, absolutely. First of all, thanks for inviting me today. Planet IQ will launch the world's first constellation of small sats entirely focused on weather and improving the weather forecast globally. You know, every soul on Earth deserves a great weather forecast, and pretty much every business wants one. So we are looking to launch our first 2 in the third quarter of next year, followed by 10 in 2017, with a specific type of technology called GPS radio occultation. And this data in particular has been found to be very useful in improving global forecasts, particularly in parts of the world that are, actually undersampled now. That would be Africa, that would be India, much of the developing world. But the data are valuable, globally to driving a much better forecast.
Okay, thank you so much for the introduction. Frank, can I request you to tell us more about OmniEarth and its activities with small satellite domain?
Certainly. OmniEarth is a company that's been formed to do big data analytics and have provisioning through satellites and other sensor data, largely to serve multiple markets around the globe. There is a trend toward the utilization of geospatial information to convert that information into solutions. That's why OmniEarth was formed. We focus very specifically on the provisioning of unique data sets. In the case of the satellite constellation that OmniEarth is constructing, it will be a global constellation for the provisioning of medium resolution, panchromatic and multi-resolution, multispectral data on a temporal resolution of every day. So what that really is trying to do is bring a level of information that is current and can be used in multiple sectors to produce solutions to customers that need that type of information to solve some of their largest problems.
Okay, thank you so much. That gives a pretty good understanding of what OmniEarth does and what Planet IQ does. Yes, definitely. Just a small satellite is a trend, and can I understand what, according to you, what is your impressions about why this trend has catching up and what has facilitated this trend? in the first place?
Well, I think it's catching up for a lot of great business reasons, frankly. I believe that it is now possible to manufacture these satellites that are equally as reliable, depending on the application, for a lot less money. In our case, we've been through 3 separate designs of the satellite, and finally we have arrived at a design that also has the appropriate risk-reward, as you would put it, for what it's going to cost to fly it. In the 3 designs, we've gone down dramatically in weight and in cost, not only to build the satellites, but then also to launch them. And there's the tremendous amount of technology innovation that's occurring in the engineering and manufacturing of these satellites. And certainly we've drafted off of those accomplishments. We just recently announced that we've signed our bus manufacturer, a company called Blue Canyon Technologies out of Boulder, Colorado, with an excellent pedigree, if you will, of building CubeSats. We actually will be in a 6U form, so it's larger than your average CubeSat, but we're able to produce these much faster at much less cost than, say, a traditional satellite that most people think of. We're down to under 15 kilograms. We have been as high as 135 kilograms. And when you look at the cost of launch, every kilogram that you save is saving you tens of thousands of dollars. So I think we've really benefited at Planet IQ from the innovation generally that's going on in the satellite market. I think the other thing that is a driving factor here is what you can finance and what the largely venture capitalists in Silicon Valley are willing to finance. What we see is an explosion in the 3U satellite form, very inexpensive satellites, and to some degree viewed as disposable, really. We at Planet IQ have not taken that approach. We don't view them as disposable. We have a 7-year design life on ours. We have propulsion on board, and so we have gone up the value chain a little bit on building a more robust satellite, I would say. But the venture capital community is really very detail oriented, and they also want to weigh their risk reward on the amount of money they're willing to put forward and what it costs to build these instruments. So I think technology and the availability of capital really are driving this.
Okay. Yes, as Annie has pointed out, every kilogram that is reduced is saving in tens and thousands of dollars for launching and manufacturing. Frank, how has been Omniel's experience in building the satellites? What kind of technology innovations have helped you?
Well, all of the types of innovations that Anne was referring to are a benefit to everyone who is looking at putting up a satellite constellation. I think the founders at OmniEarth had really pretty much a different vision in terms of all of the devices that can provide information and data to fuel an analytics solution to solve problems. So the satellite constellation is very important in our data provisioning and the types of data streams that we'll be providing to customers. But we receive data information from all sources of information: aerial, sensors, social media, demographic information, and it's the fusing of that information into the solutions that really counts. So as we progress, as the company executes its strategic plan, 3 years from now we'll launch a constellation of 15 satellites, 18 with in-orbit spares. These are slightly larger than the ones Anne described, but they have a different capability. It's actually an optical telescope with multispectral sensors for bringing in high quality, scientifically calibrated data that will allow analytics to be performed in a temporal way, and through the combination of that with other information, very unique problems can be solved. Secondly, the satellite will also contain hosted payload capacity, which in this case it's approximately a 300 kilogram satellite, and about 80 kilograms is reserved for hosted payload capability. That can be other sensors, that can be communications devices, it can be things that work in conjunction with our system. So we're capitalizing on the advent of the same technologies that Ann talked about, only in a little bit larger format for the type of coverage we want, which is actually a global, everyday, everywhere coverage.
Okay, just to get to the basics, what is the specific need for having such huge number of satellites and have a constellation together?
Well, I think the trend toward the global coverage is there. The actual quantity of satellites in this case is not really that large. It's 15 satellites in the sense of many other constellations, famous constellations such as Iridium, were 77 with its spares. The most recent communications constellation was announced, OneWeb, will be 700 satellites. So the quantity of satellites and the purpose and the function that's actually going on is really what is geared toward it. So we don't view our constellation to be an extremely large number of satellites in that sense.
Okay, okay. And my next question goes to you. You talked about how cautious the venture capital community are becoming in terms of the risk, in terms of the cost implications, and other things. How you as a company are able to convince him about the proposition and the reliability of this kind of constellation?
Yeah, so I think in our case we have some unique obstacles, challenges, opportunities to overcome, in that there are no private weather satellites anywhere in the world. And the most important thing in a business is one of the most important is certainly the market. We know that the world's global forecast agencies want to buy this data. They want to use this data. They want as much of this particular type of data as they can get. The world's premier weather forecasting organization, the European Commission for Medium Range Weather Forecasting, said that you could have 130,000 occultations a day, which is roughly 50 satellites worth of data, and still not saturate the global forecast models. The world now, the major forecast centers around the globe want as much of this as they can possibly get. The issue is they've never bought it before. They all buy data at present. They buy land-based data and they buy aircraft-based data. But from satellites, that transition has not yet occurred. I used to work for the National Oceanic and Atmospheric Administration. I worked there at the time when the commercial imagery world was trying to come out of the ground, before there was a Digital Globe or an Omni-Earth or any of the others. And the intelligence community was not the least bit excited about allowing this commercial entity to come out of the ground and start to provide imagery around the world. But they found themselves in a situation very akin to the situation today that NOAA finds itself in the global forecast agencies. And that is that we have a gap in coverage for weather satellites. Those weather satellites have gotten exceptionally expensive, billions of dollars apiece. True. Their build cycles are 13 years long, and there's no ability to innovate. And at that time, that was called the Future Imagery Architecture. That constellation was desperately behind schedule and over budget. And the leadership of the intelligence community said, well, maybe we should be working with the imagery providers, the commercial imagery providers. We're starting to see that same transition. It's a behavioral transition occur in the weather satellite business. So we know there's a demand for the data. We just know that there's a cultural impediment to buying the data. Presently, the globe spends about $6 billion a year on weather satellites. So there's plenty of budget out there to support 1, 2, 3, 4 commercial companies. It's actually, I would argue, a bigger market than selling imagery is. It is a bigger market and will prove to be. And I think the downstream analytics as well are huge from these data sets. What we see out of the venture capital community is, they'd like to get a little more comfortable with the market and the buyer behavior. But they're willing to, they see a home run here and they're willing to invest, much like they have recently in a number of imagery companies, whether it was Skybox or Planet Labs or Black Sky. I mean, there are a whole host of really innovative companies coming out of the ground now. So I think they're willing to step forward.
Okay, that's a good piece of information, because Earth observation satellite for a small satellite as a means has a proven market, but I think for the weather satellite, the market is yet to be proven, and
Right.
but the potential is humongous, I guess. That's
Well,
what
and
I
we're
think.
also seeing a lot of innovation in weather forecasting in particular. So you're seeing the growth of companies like the Weather Channel, like AccuWeather, like Japan Weather News, like the Meteo Group. Those companies are now doing their own numerical weather prediction, which means they have an ingest cycle for that numerical weather prediction and an assimilation technique, and they can use this type of data as well. So we're not constrained just to government markets.
Yes.
We will also be selling into commercial markets. And I think you're going to see that commercial sector grow dramatically over the next 10 years. You know, the Earth's atmosphere is just a finite element model, and it's one that we dramatically undersample now. And so to the extent that we're seeing the increased power in compute platforms and better algorithms and better research, fundamental research, supplying better observations faster, a lot more of them, and being able to innovate in that space should drive a dramatically better weather forecast.
Okay, fantastic. Frank, moving to you, the small satellites have been already in the process of sending out Earth observation imagery. And how do you see the data can be used? For what kind of applications can this data be used along with the analytics and get to a more action-based information?
Well, our business plan actually goes across an existing market for medium resolution information. This information has been used for many years. However, it has not had the same type of consistency and temporal resolution and focus that needs to be there to provide really good coverage and filling in the gaps, as Ann said, to serve various types of markets. So the types of products that we are going with really go into commercial markets like agriculture, energy, utilities, civil governments, and it is more of a business-to-business type of business model. We do have U.S. government as part of the business plan, but it's a small part. The growth is largely in the commercial sector, and that's where the promise is. And several of the critical products that are actually on the front end of this analytics drive really have to do with, recently we introduced a series of products that address the continuing crisis and drought in California. These products allow the various water districts, there's 400 different water districts in California, that allows them to understand parcel by parcel what the utilization of water is, why it is what it is, what the budgeting and rate structure should be, data that has not been provided heretofore. And this is largely being captured by existing satellite imagery as well as aerial imagery and other information that comes from vast data sources that the state has, the municipal water districts have. And by combining that with companies and teaming with companies that are experts in indoor water use, we add land classification and feature extraction and a set of algorithms that allows for very precise prediction and understanding of the water utilization. That allows for the proper programs to be put in place to address, for example, in this case, a drought and water crisis. In agriculture, similar types of methodology are used by the engine that we have, but we tailor the application from that engine to directly looking at crop yield predictions, different types of crops, different types of distress, and the like. These are classic applications that have been provided. But what is unique is really the large data set computations that are afforded by really data scientists now and cloud computing that can bring that set of solutions to the market rather quickly and solve problems quickly. So it is a really exciting time to be looking at this type of market and then adding through really expertise in the sensors and the types of sensors that should be provided and where to collect that data and how to actually integrate it into the analytic solutions that is really what our company is set up to do. So we're not limited to just this satellite constellation or this set of sensors or this one type of data. We go across the board, including probably someday being a customer of Planet IQ with Ann for weather information.
Considering that Omni Earth is using the small satellite data and also any data required for creating more solutions, how do you see how competitive or how good is the small data from the small satellites vis-a-vis the data that you obtain from the larger satellites and the conventional satellites, and how a mishmash of these two imageries can be very seamlessly brought in together for effective solutions?
Well, that's a very important question. I think it's more of an ecosystem, and there are many different types of capabilities that are brought to bear by satellite technology. If you were to look at transportation, for example, there are semi-tractor trailers and there are Mini Coopers, and so they provide a whole series of transportation functions tailored to the types of needs that you have. The technology has changed, so actually there were very large satellites built in the 70s and 80s and 90s for the government. They were governed by the shuttle cargo bay. That was actually what governed the limit, and so the idea was, for the amount of capital that was going to be invested in those systems, you would put the maximum amount of capability. You can only build 5 or 6 or 7 of those systems. True. Then came the advent of a telecommunications market with commercial GEOs. These satellites are 6 metric tons. There's hundreds of those, not 6, not 10, but there's hundreds of those. They were governed by the most capability that commercial launch providers could provide in a 5-meter fairing to that. So the idea then was to maximize the amount of electronics you could put in there and maximize the amount of coverage you could have to deliver and transport communication and bandwidth. Small satellites have come and they go to hundreds or thousands now. And the functions that they perform are quite a bit different, sometimes similar. But the temporal resolution and the rapidity of putting up different sensors quickly and the resilience of the network is really what is starting to be an advantage. But if you think about it, where did all this come from? That will not scale to billions, millions or billions, whereas these smartphones have scaled to billions now. And within here there are sensors, there's two cameras, there's a microphone, there's an accelerometer, there's a GPS receiver, a cellular receiver, an infrared device port on it. And so when you think about the electronics that are actually going into satellites, this is where it has been driven by that scale has allowed that to occur. So the next thing that we see in this is really part of what's called the Internet of Things. And that gets to, this is not scalable to trillions. So you would want trillions of sensors, actually, if you're going to monitor everything in the world, and that includes the use of satellites. So as you bring this down to nanoscale, there are radios that are nano radios now that if you look at a penny and put a dot on Lincoln's eyebrow, that's the size of a nano radio. It does not have a battery, it has about a kilometer transmission rate. Stanford University's actually prototyped this. So these sensors will be everywhere. So what Ann was referring to in terms of a finite measurement of the atmosphere, there'll also be a finite measurement of everything that is geographically measurable and physically measurable on Earth, which is really the wave that we're capitalizing on in terms of providing data scientists and space experts that can then convert that information into useful solutions for the customers.
Okay, thank you, Frank. Before we run out of time, and I would like to ask you, Planet IQ is building a constellation of weather satellites where I think most of the satellites are government-owned and the conventional set of satellites. So how do you see the data and the information coming from these small satellites, weather satellites, would be faring vis-a-vis the conventional satellites?
Well, I think we have a couple of advantages there. One, there is a constellation on orbit called Cosmic One now, which was a joint program with the Taiwanese government and the United States Air Force and the National Science Foundation. The instruments on Cosmic One proved the utility of GPS radio occultation data to dramatically improving the forecast. Our founder built those instruments, also built the instruments that are on Cosmic 2, which will launch next year in an equatorial orbit, again through the country of Taiwan. So we have the intellectual property actually that has driven the application of this data, GPS radio occultation data. So we know what we're building, and we're now building the 4th generation of this sensor. The quality of the data and the amount of data will be higher than anything any of the governments have ever seen before. We'll be measuring data off of all 4 GNSS constellations, so GLONASS, Beidou, Galileo, and GPS. And we'll have a superior signal-to-noise ratio over the previous instruments, allowing us to get down, way down into the troposphere to the surface of the Earth. 32,000 occultations a day, equally surrounding the globe, equals about 8 million measurements of temperature, pressure, and water vapor, equally surrounding the globe. And that's the most accurate measurement of temperature that exists. So we're very confident that this will be the highest quality data anyone's ever seen before, because this team has built 20 of these instruments on orbit. And I agree wholeheartedly with Frank. It's not just about the data. It really isn't about the data. It's about the application of the data, whether you're in the imagery world or in the weather world. It's about helping society or business solve their problems. And we need to focus on those end use applications and a little less on the data itself.
Yeah, I think you hit it on the nail. It's not just about data, it's about the applications and the use of data and information to create more applications that would solve the real world problems. Thank you, Anne. Thank you, Frank, for joining us on GeoBiz, the live panel discussion on the small satellites. Thank you so much for watching us. Bye-bye.
Ta-da.